Okay, in this video, we're going to go into some very heavy physics content. We're going to talk about projectile motion, how it relates to parametric equations. Parametric equations are very often used to model projectile motion, and this is any object that's fired, shot, launched, whatever, such as, or even a basketball shot, anything that has that parabolic projectile motion. Parametric equations are used to model this if an object is projected at an angle of elevation of theta. So it's launched at an angle of theta. The horizontal distance and the vertical position of the object can be represented by the following parametric equations. The horizontal distance represented by this equation, x equals t, which again t stands for time, times v sub 0, which v of 0 is your initial velocity or your initial speed. And that's anytime you see that subscript of 0, that's usually a starting velocity. And then again, theta, we've already said that theta was your angle of elevation, of launch. And then your vertical position can be found by this equation. Y is equal to t times v sub 0 times sine of theta. We've already talked about what all those variables represent. Minus 1/2 gt squared, where g is your gravitational constant, plus h of 0, which is your initial height. The gravitational constant, now let's talk about gravity, is the acceleration of an object due to gravity. It's how quickly an object falls as a result of gravity. At the surface of the Earth, this is 9.8 meters per second squared, or 32 feet per second squared, all depending on if you're talking about in meters in the metric system or feet in your standard units there. Okay, example 1. Mark kicks a soccer ball upwards from ground with an initial velocity of 75 feet per second at an angle of elevation of 62 degrees. So again, your initial velocity is given there, 75 feet per second, and you have a theta of 62 degrees. Make a diagram of the situation. And here's my diagram that I drew. I drew this black arrow, this black vector here, saying that if you kick it at this angle of 62 degrees, it's going to follow that angle, but then gravity is going to start pulling it down, and eventually it's going to reach its maximum point and then come back down to the ground. Write a parametric equation to describe the horizontal and vertical position of the soccer ball at time t. So your parametric equation, your x value again is equal to t times v sub 0 times cosine of theta. So t times your initial velocity, which is 75, times the cosine of theta, which is 62 degrees. So there's your x value. Your y value is going to equal, again, it's t times v sub 0 times sine of theta. So t times 75 times the sine of theta, which is 62 degrees. That was your angle. Minus 1/2 times gt squared. So minus 1/2 times g. And since we are talking about feet per second, we're going to use 32 feet per second squared is going to be my gravitational constant. So 32 times t squared. And then your initial height, your h of 0, it was given right here. It's kicked upward from the ground. So your initial height is 0. So now it's simply clean up. Let me zoom in a little bit. So your x value is fine. We'll just leave it like that. But your y value could be cleaned up into t times 75 sine of 62. And that would be a decimal there. Half of 32 would be minus 16 t squared. And then you don't have to put the plus 0. So therefore, there's your y equation. C part. Find the horizontal distance the ball has traveled after 2 seconds. So let's take our x equation and write it down here. And to find out where we're at after 2 seconds, we're simply plugging in 2. So I'm going to find x of 2, which would be 2 times 75 times the sine of 62. And again, that's just going to be all calculator work. Type that into your calculator, and you're going to get about 70.42 feet. Now, again, since they were talking about, notice the horizontal distance. The x value is how far left and right the soccer ball is going. Has nothing to do with how high it is. So after 2 feet, it has traveled horizontally. It will be in the air, but the horizontal distance from the starting point will be 70.42 feet. So would be somewhere like if you had this as 1 second, 2 seconds, how far has it traveled from here over to here? That's what you just found. Find the vertical position of the ball after 2 seconds. So to find the vertical position, we're going to use our y graph right here, our y equation. So we're saying how high is it after 2 seconds? So that'd be 2 times 75 times sine of 62 minus 16 times 2 to the second power. And again, it's all just plugged into the calculator, and you get 68.44 feet. So after 2 seconds, it has traveled 70.42 and is 68 feet in the air. Next one. A tennis player serves a ball with an initial velocity of 35 meters per second. The ball leaves the racket at a height of 2 meters and at an angle of elevation of 45 degrees. So let's make a diagram of the situation. Let me draw me an XY axis. And here's my diagram. So we're 2 feet above the, right there, or 2 meters, excuse me, above the ground. The angle of elevation that we hit the ball is with an initial velocity of 45, angle of elevation is 45 degrees. So that ball is going to follow that angle, and then again, gravity is going to start pulling down on it, and eventually it will hit the ground. So there's my diagram. Write a parametric equation to describe the horizontal and vertical. And again, all we're doing is plugging in to our x equals and y equals equations. X equals t times v sub 0 times cosine of theta. So that'd be t times your initial velocity, which is right here, 35 meters per second, times the cosine of your angle, cosine of theta. Now, we know the cosine of 45, so if we want to go ahead and put root 2 over 2, we can. So let's clean that up a little bit. That's going to be t times 35 root 2 over 2. So there's your x equation. Your y equation. Y was equal to, let's scroll back up, t times v sub 0 times sine of theta. So t times v sub 0, your initial velocity, which is 35, times the sine of your theta, which is also root 2 over 2. And then you have minus 1/2 gt squared. So minus 1/2 times g. Now, since you are talking about meters per second, now we're going to be using our 9.8 instead of our 32 since we're in meters. So let's do times 9.8 times t squared. And then it was plus h of 0, which was your initial height, which was 2. So now let's clean that up just a little bit. We can do t times 35 root 2 over 2. Minus 1/2 of 9.8 will be 4.9 t squared, and then plus 2. Now, I like to write that in order, descending order. So if you want to write this minus 4.9 t squared first, you can. But that is your y position. So there's your y, and here is your x. Let me go ahead and erase this and scoot this over. And there is your x. Okay. C part says find the horizontal distance the ball travels after 1.5 seconds. Since it's horizontal, we're finding x of 1.5, or we're simply plugging in 1.5 into our x equation. That'd be 1.5 times 35 root 2 over 2, which is, again, all calculator work. Let's type that straight into our calculator, and you get about 37.12 meters. Find the vertical position. Now, this is after 3 seconds, so we're finding y of 3. So let's take our y equation right here and simply plug in 3 for this t and plug in 3 for this t. Again, all calculator work. Type it in, and you get 32.15 meters. And that's it. Number 3, example 3, a football is kicked from the ground. So your h of 0 is going to be 0 at an angle of elevation of 45 degrees with initial velocity of 60 feet per second. How long is the ball in the air? So now it's a little bit different. So since we're talking about how long is the ball in the air, and we are going to find the horizontal distance over here, let's go ahead and find our x equations and y equations. And I'm just going to write these right here. I'm just going to go ahead and plug in all the values for you. And there they are. So how long is the ball in the air? So again, let's talk about this. As a ball is kicked, when it hits the ground, what you need to remember is that your y value is equal to 0. So since our y value is equal to 0, we're going to use our second equation. And we're going to simply take that second equation and we're going to try to figure out at what time will my y value be 0. So take your second equation, which is, and I'm going to put those in order. Like I said, I like the t squared first since it is quadratic. Negative 16t squared plus t times 60 times sine 45. I want to know when that is equal to, that's the height, that's my y value. I want to know when that is equal to 0. And all you're going to have to do here is, first off, you have two terms. Factor out a t. So when you factor out a t, you're going to be left with negative 16t plus 60 sine 45 is equal to 0. Set each of those factors equal to 0. Here's a factor and here's a factor. Now when you set this first factor equal to 0, you just get t as 0. And we'll talk more about that in a second. Set your second factor equal to 0, and let's solve that. Let's move our 60 sine 45, which we can actually, that sine 45, if you want to clean that up, that is root 2 over 2. And this would cross cancel right here and give you a 30. So let's move that 30 root 2 over, and it gives you negative 16t equals negative 30 root 2. Divide that by negative 16. You can cross cancel, reduce, and all that, but you're going to type it straight into your calculator anyway, and you're going to get about 2.65. So, and that's in seconds. So at time equals 0 and at time 2 equals 2.65, your y value is 0. What does that mean? You kicked it from the ground. So that's the reason at time equals 0, the ball was at 0. And after 2.65 seconds, it hits the ground again. So therefore, it was in the air for 2.65 seconds. Find the total horizontal distance the ball traveled. We knew it was in the air for 2.65 seconds. So what we need is the x value when it hits the ground. How far did it travel? Well, it traveled for 2.65 seconds. So let's simply take our equation, our x equation, because we want to see how far left and right it traveled. Let's plug in 2.65 here. So you're going to do 2.65 times 60 times the cosine of 45. Just type that straight into your calculator and you get 112.43, and this was in feet. The next example, example 4, a baseball player in the outfield throws a ball towards home plate. The ball leaves his hand from a height of 6.5 feet. Initial velocity is 110 feet per second. So let's go ahead and write our equations right here. And there they are. Now, I do want to point out they did not give us an angle of elevation. They give us an initial height, which was 6.5, an initial velocity of 110. Since we were talking about feet in both of these, then we use 32 for our acceleration due to gravity. And there's our two equations. The ball is caught by a player at home plate after 1.8 seconds. If the ball traveled a horizontal distance of 191 feet, find the angle of elevation. So we're talking about the distance it traveled, left to right, how far it traveled. So we're going to use our first equation. If it traveled 191 feet, we're going to plug that in for our x. So 191 equals, our time that it took was 1.8 seconds. So we have 1.8 times 110 times the cosine of theta. Let's solve that. We can multiply these two together and then divide by the answer. And that's going to give me the cosine of theta is equal to 0.9646. Now, since the cosine is equal to a positive, let's make sure that we understand that this is going to be somewhere in the first quadrant. Cosine is negative in the second quadrant, so you don't have to worry about that. And there's absolutely no way that we're worrying about an angle between 270 and 360 for this application problem. When we do the inverse cosine, we're going to find out that our angle of elevation is about 15.28 degrees. B part. What was the height of the ball when it was caught by the player at home plate? So we're talking height, so now we're talking a y value for our parametric equation, and we do have a theta now. So all we have to do to find out the height was we know that it was caught after 1.8 seconds. So we're going to plug in 1.8 into our y equation. And along with that 1.8, we now have an angle of elevation that we can plug in. So we're going to do 1.8 times 110 times the sine of 15.28 minus 16 times 1.8 squared plus 6.5. We're going to simply type that whole thing into our calculator, and we should get about 6.84 feet. The next one. Example 5, a projectile is fired from the top of a 24-meter tall building. So we have an initial height, that's our h of 0. At an angle of elevation, there's your theta, with an initial velocity, so that's your v of 0, 55 feet per second. What is the maximum vertical height reached by the projectile? Let's go ahead and find our two equations, and I'm just going to write these right here. So there are your two equations. And again, our first one says, what is the maximum vertical height reached by the projectile? Now, I do want to share this with you. If any time you have something that's fired from the ground, that maximum height will always occur between the initial fire being shot and however long it took. So you could actually, if it's fired from the ground, you could find how long it takes for it to hit the ground again and then just take half of it. And that's where it's going to occur. However, this one's a little bit different. It's fired from a height and then it comes down. So it's not going to be right in between the starting time and the ending time. So it's going to be a little bit different. So what we're going to do, what is the maximum vertical height? Here's how we're going to work this out. The maximum height occurs at your vertex. And the vertex of a parabola, same way here, occurs at negative b over 2a. Now, here's what's going to be different about this. If you take this y equation, when you do negative b over 2a, that's going to tell you the t value because this is a ty graph, not an xy graph. So it's going to tell you the t when you're going to reach that maximum point. So t is equal to negative b over 2a. That would be negative b. Now let's put these things in order. Now that's another reason I like for them to be in order. That's negative 4.9 t squared plus, and you could even put this 55 sine 28 first if you wanted to, t, and then plus 24. So negative b over 2a would be a time of negative b, which is 55 sine 28, over 2 times a, and your a value is negative 4.9, so it'd be negative 9.8. Type that straight into your calculator, and you get 2.63 seconds. However, that did not answer the question. That was the time when it reaches its maximum height. Again, we plugged that in to our vertex formula there. But the actual maximum height is going to occur at 2.63 seconds. So we're going to take our y equation now, and to find out how high it is at 2.63 seconds, we're going to plug it in. And when you find y of 2.63, plug that in, you get a height of 58.02 meters. So that's your maximum height. Find the horizontal distance traveled by the projectile at the time it reaches its maximum height. So it reached its maximum height at 2.63 seconds. So we're simply looking for the horizontal distance traveled at 2.63 seconds. So we're just going to plug that into our x equation to find the horizontal distance, and you get 127.72 meters. C part. If the projectile is fired towards a taller building or a building taller than 300 meters away, Will the projectile hit the building? If not, how far from the building will it land? So first off, we've got to figure out how long is it going to take this thing to land. Once we find out how long it takes to land, then we can see if it's going to hit this building 300 meters away. So to find out how long it takes to land, again, we're going to take our y equation because, and let me put this in order, negative 4.9 t squared plus, and again, I like to put the 55 sine 28 first. And I'm going to put it in parentheses because that goes in front of the t, plus 24. That tells you the height. We want to know how long it takes to land. So we're going to set this equal to 0, and that's going to tell me the time that it takes to land. Let's factor our t out, or you can use quadratic formula. I'm much more, well, we can't actually factor the t because you have 3 terms on this one. It's not going to be like the last one. So we're going to have to use an ugly version of a quadratic formula here. You have a t value, because I'm pretty sure it won't factor. T is equal to, not x this time, but t is equal to negative b plus and minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Again, not the cleanest looking formula, but it will tell you that the time it takes, you can type the whole thing into your calculator. The time it's going to take this to land is going to be negative 0.81 or 6.08. And again, this is a parabola, and the reason I gave you that negative is it was launched from a height and it lands here. However, you would have, if it was a full parabola, you would have another x-intercept at negative 0.81, which we can throw out. Because again, it's not a full parabola. Our domain here is actually only from here to here. So after 6.08 seconds, it's going to land. So the next question is, how far does it go? And we're saying how far does it go? That's an x value. We're finding, okay, the distance traveled till the time it hits the ground. How far did it travel in that 6.08 seconds? So what you're going to do now is you're going to take your x equation, plug in 6.08 for your t value, and you're going to find out that the x value that it travels is going to be 295.26 meters. So the building was 300 meters away, so it lands 4.74 meters short of the building. It does not hit the building. So using these parametric equations, what's nice about them when you're talking about projectile motion is you can find the height, the length, how far it goes, how high it is at any specific moment, at any specific time. So it adds that third parameter of time, so you can follow, you can track this thing by second by second.